Test, test, test. Welcome, ladies and gentlemen, to another exciting edition of CDT Study Club. I am your host and host. That's it. I'm your host. Lee Coursey of Russellville Dental Laboratory, a small little dental laboratory in Southern Kentucky. And today we are going to be, once again, taking a look at what we need to do to get through the CDT Study Club. Specifically, right now we're practicing for the comprehensive exam. So what we have is a CDT Study Club. If you're a viewer from outside of Russellville Dental Lab's team, let us know in the chat and I will give you access to the CDT Study Club, the comprehensive exam study guide that we're building together. It's a collaborative study group. And just the basics, this is, you have to take 3 tests in 4 years. There's one general exam, there's one exam, multiple choice. There's one exam, multiple choice that you have to do that is specific to your area of study, and then there's a practical exam where you actually have to do a hands-on exam, and you will have to go to that exam unless you live near a center, a testing center, but you do not. If you're watching this viewership right now, you're probably not living near a place. So, yeah, I was looking for the piece of paper here that has all that information, but anyway. So moving on, I think we're all familiar with Google Slides at this point. If you're not, please know it's pretty straightforward. All we're going to do is make some new slides here. We're using this template, and we will work together. Again, content, the biggest portion of content is from materials. In our team, we are using Elsevier's Dental Materials book, and there's also the one that's officially recognized by the CDT National Board of Certification, but this one's on the, this one's pretty good. So Wheeler's Dental Anatomy, which is actually now out of print from 2009. There's not a current version of it, so we've been using Dental Anatomy from Elsevier. Also last week I flaked and did not finish my test online in real time, so I am going to finish that test in real time without looking up any answers, and will not go down the rabbit hole this time, I swear. And then these are the books that you're using. So there's that Wheeler's Dental Anatomy, and also the Elsevier. Let me just pull that up and put that. So this is exactly how I would do it. So Elsevier Dental Anatomy, and where is that book? It was an Amazon. Okay, so there's a Wheeler's Dental Anatomy. The one we were working with, though, okay, dental materials. Sorry, dental materials. I apologize. Dental materials. So I'm going to go ahead and pull this up. Right click, copy image. Pull this up here. Control V. Paste it. Oh, I guess we will not do that. So this is dental materials and foundations. Right click, search Google, and I bet if we click on images, we have this right here. I bet that one's bigger. Copy image, pop this in here, Control V. So that's the one that we're kind of using around the lab here. All right, so let's go ahead and get started. Tonight I am going to finish that exam because I want to see what that said. I want to get in there and finish that up and see what my knowledge level is. I need to go, what was that? Elsevier Plus, I think is what it was called. One moment, please. Elsevier, Evolve Content Player, Student Resources, My Evolved. You are not logged in. Please go back to your learning management system. Elsevier Education Portal. Bomb. I bet we created an account for this already. What do you think? Continue. Sign in. We did. We agree. All right. Yes, I agree. No. I really agree. Here it is. So you want to go to evolve.elsevier.com, and when you purchase this book, as you have, and completely and totally purchase this book and have the way they know that you purchased the book is that you have the ISBN number. If you have that book, you can go over to evolve.elsevier and you can access any of their materials. Let's see what else they begin. What else they have. Chapter 1. So last week we were doing the quiz on this, and there was a practice quiz. There's instructional videos, case studies. So these are case studies that are, in rich text format. No, thank you. How nice of you. I'll skip that. I'm going to go back and I'm going to finish that practice quiz that I had started. All right. So which of the following is RUB cast about oral disease, restorative dental materials? Phonics. Yeah, we're going to go with that. Which of the following can be directly related to tooth damage? All of the above. There is evidence to support more than a casual link between oral health and which of the following? All of the above. Which of the following factors cause dental caries? Sugar, bacterial plaque, soft cementum, all of the above. Soft cementum, bacterial plaque. Which of the following cause dental caries? Bacterial plaque. The most common place for plaque to accumulate is which of the following? Pits and fissures of teeth. smooth interproximal surfaces of teeth, at the cervical third of the tooth, all of the above. All of the above. Question 6. Which of the following statements is true regarding periodontal disease? It rapidly destroys the softer cementum of older individuals. It can be fatal. It is caused by bacterial plaque, both A and C. It's just A. So, it rapidly destroys the softer cementum. All right, rabbit hole time. Search Google for cementum. Cementum. All right. Wikipedia tells us that the cementum is I was going to say it was this area right here. What is G? Show me your terminology. Haha. So the cementum is here. So the cementum is this boundary layer, soft boundary layer of the tooth. And so periodontal disease, going back to our thing, because I'm not flaking here. Which of the following statements is true regarding periodontal disease? It rapidly destroys the softer cementum of older individuals. Okay, cool. All right. What is inflammation of the gingiva called? Gingivitis. To what does anaerobic refer to? Bacteria that survive in an oxygenated environment, a low or no oxygen environment, deep pockets around the teeth, the harboring of plaque or other damaging bacteria. Anaerobic is a low or no oxygen environment. Yay. Question 9. Which of the following statements is true regarding the relationship between diabetes and periodontal disease? Diabetes causes periodontal disease to progress rapidly. A person with diabetes may experience a worse case of periodontal disease than someone without diabetes. Yes. I'm going to go with this. Okay, so I got it wrong. Diabetes. Which of the following diabetes causes periodontal disease to progress rapidly, and a person with diabetes may experience a worse case of periodontal disease than someone without diabetes. Okay, cool. Yeah, this is not. I'm going to get through this one quick. Which of the following conditions may require a restorative dental procedure? Yep. Yeah, we're going back. This is not the one I was doing. Chapter 1, properties of materials, preventative dental materials, mineral amalgam, impression materials, waxes. Ooh! Properties of materials, practice quizzes. There we go. I think this is where we were before. Which of the following describes dimensional change? A measure of how much a material expands, the measure of thermal conductivity, the percent shrinkage of expansion of a material, the generation. No, yeah, it's number 1. It's not. The percentage shrinkage or expansion of a material. I glanced over it. This is damn my ADHD. I don't have ADHD. It's just not paying attention. It is important to maintain dimensions during dental procedures for which of the following reasons? Aesthetics, to preserve accuracy of dental restorations, to prevent chemical reactions, all of the above. Maintain dimensions. I'm not batting 1,000 on this, am I? I'm going all the way through. Which of the following statements is true regarding thermal dimensional change of restorative dental materials? A differential expansion of dental material and tooth may result in leakage. Thermal expansion of the restorative material usually does match that of the tooth structure. The thermal coefficient of expansion for a solid generally decreases as the temperature is increased. Thermal coefficient. The thermal... I'm just going to go with the simple one here. Boom. The thermal expansion of the restorative material usually does not match that of the tooth structure. A differential expansion occurs that may result in leakage of oral fluids between the restoration and the tooth. Thermal expansion of the restorative material usually does not match that of the tooth structure. The thermal coefficient of expansion is for a solid generally increases as the temperature is increased. The thermal coefficient of expansion is not uniform throughout the entire temperature range. All right. Which of the following restorative dental materials has unusual percolation characteristic? Ceramics. No, it's amalgam. Okay. Materials with high thermal conductivity values are good conductors of heat and cold. Materials with high thermal conductivity values are good conductors of heat and cold. Metals. Metals have higher conductor values than polymers and ceramic. Materials with high thermal conductivity values are good conductors of heat and cold. Both statements are true. Which of the following dental materials are considered to have low thermal conductivity properties and would be ineffective as thermal insulators? Low thermal conductivity, meaning they don't transfer heat, and they would be ineffective as thermal insulators. We're going to go with this one. Nope. Cavity varnishes. Of the following terms, which refers to the generation of electrical current resulting from the presence of dissimilar metals in the mouth? I know this one. Galvanism. So here's a quick one for you. For those of you who are watching who work with metals, if you work with, even if you're not the one producing or casting metals or milling metals, you want to make sure that you don't, for example, put like a high noble metal with a base metal, because the galvanic reaction that you get between the two can be significant. One of the most common ways that you're going to see this is if you take a ouch, that hurts. If you take a non-precious PFM and put it on top of, say, a gold abutment, it doesn't work right. So yeah, galvanic reactions can happen between dissimilar metals, specifically between baser alloys and high noble alloys, but I think there's other things as well. The surface reaction of metals in the mouth from components in saliva or foods is which of the following terms? The surface reactions, so tarnish. Tarnish is the surface reaction, yeah. Which of the following terms refers to the dissolution of metals in the mouth? Corrosion. Dissolution of metals in the mouth. Corrosion. Hydrophilic means no water. Describes a solid that is wetted readily by a liquid. False. Hydrophilic describes poor wetting of a solid by a liquid. True. The first statement is false. The second statement is true. Are you kidding me? Hydrophilic wetted readily describes a solid that is wetted readily. Hydrophilic. Wetting is the ability of a liquid to maintain contact with a solid surface. So wetting in this case would be high. Okay, I got that wrong. Of the following terms, which one refers to the ratio of the force to the area of distribution? Of the following terms, which one refers to the ratio of the force to the area of distribution? Stress. What is the term used to describe the force that results when pulling materials apart? Shear stress. What's the difference between tensile and shear? Tensile stress refers to cases when a deforming force acting perpendicular to the surface of the object pull on the object. So tensile stress is pulling and shearing is ripping, basically. Yeah, so elongating is tensile strength. Elongating is tensile strength. Shearing is or breaking. Okay. Yeah, I'm not doing that one. We're doing this one. That's right, viewers. We're failing live on air. The elastic modulus is a measure of the stiffness of a material. Impression materials should have a low elastic modulus value so that they can be readily removed from the mouth. The elastic modulus is a measure of the stiffness of a material. Okay. Impression materials should have a low elastic modulus value so that they can be readily removed from the mouth. Both statements are true. Yep. Okay, so the elastic modulus is a measure of the stiffness of a material. Yes. Low elastic modulus would be flexes a lot. So high elastic modulus would be stiff. So high would be more towards stiff. Low would be away from stiffness. So a low elastic modulus would be flexible, and it needs to be flexible to be readily removed from the mouth. Cool. All right. Question 14. The stress at which a material no longer functions as an elastic solid is which of the following? Yield strength, proportional limit, ultimate strength. I'm going to go with both A and B. Yep. Which of the following reasons explain why proportional limit and yield strength are important to dental materials? A restoration can be a clinical failure when a significant amount of tarnish occurs. That doesn't have anything to do with proportional limit and yield strength. A restoration can be a clinical failure when a significant amount of wettability occurs even though the material does not fracture. No. A restoration can be a clinical failure when a significant amount of permanent deformation occurs even though the material does not fracture. So proportional limit and yield strength, thinking about shear force, let's take the cusp of a gold crown. What we don't want is the cusp of the gold crown to deform, right? So we wouldn't want it to move. So which of the following reasons explain why proportional limit and yield strength are important to a dental material? A restoration can be a clinical failure when a significant amount of permanent deformation occurs even though the material does not fracture. So there we go. All right, next. The point at which a material fractures or ruptures is which of the following? That would be fractures or ruptures. I'm going to call that the shear strength. That is the ultimate strength. Fractures or ruptures. Okay, so when it deforms, all right. All right, so let's take this yummy, delicious Cliff Bar here. When I am applying a force to a material, when it gives to that force, that's its ultimate strength. So think of it as what is the hydraulic press channel on YouTube? That's the ultimate strength. Tensile strength is if we stretch this package as far as we can, and shear strength is if we, well, basically if we hold it tightly here and just go down this way, we would shear it. Okay, I'll be with you later. Ductility is the measurement of which of the following? Ductility is the measurement of which of the following? Brittleness, moldability, ability to be hammered into thin sheets, and shearing stress. So I'm going to go ductility is the measurement of which of the following? I believe that's the ability to be hammered into thin sheets. That was wrong. Brittleness. Ductility is a measurement of which of the following? Brittleness. So when do metals become brittle? Well, depending on the metal, it can be when they're very cold. We all know Terminator 2000, so we've seen it. We know. The energy required to deform a material permanently is a criterion of its malleability. The energy necessary to fracture a material is a measure of its hardness. Yeah. The energy required to deform a material permanently is a criterion of its resilience. The energy necessary to fracture a material is a measure of its toughness. 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 Hardness is the resistance of a material to deformation. To indention. To indention. Okay. All right. So, all right. That's, all right. So once again, let's take our Cliff Bar. And if we've got, we were talking about that ultimate strength is that point where there's no longer give from the material, but there is a give way, like it just goes, right? So in this case, hardness is the resistance of the material to even showing a dent. And then, so like lead or tin, those things have low hardness. They will show a dent easily. Some metals have a higher hardness, but a lower toughness. And I would say that is like aluminum. So aluminum has like it has high elasticity. It reforms after it's been deformed, and it is very hard, but once you tear it, it just starts tearing. So I got another one wrong. I'm 50-50. We'll do this again sometime and be excited about it. Which of the following terms refers to the resistance of a material to indentation? We just learned this. Hardness. Woohoo! 53%. Which of the following terms? No, which of the following? There's a comma there. There needs to be a comma there, lady. Of the following, which term is used to measure the energy absorbed at high rates of strain? Of the following, which term is used to measure the energy absorbed at high rates of strain? Let's see, either static properties or dynamic resilience. Boom. Dynamic resilience. Complete. You scored 55% correct. I don't think I'm going to pass that. We have some work to do. We have some work to do. All right. Practice quizzes. Cements. Let's do cements next. Which of the following is the type of cement used for final cementation of primarily alloy crowns and bridges? Which of the following? Okay, so I know that there's different. I'm gonna guess glass ionomer cement. I'm guessing glass ionomer cement is made for etched surfaces. So that leaves either calcium hydroxide or zinc oxide usually, or Zoe. I think Zoe is the cement that they used in. If you have an impression tray, and they're using that rubber-based material. You'll see them coat the inside of an impression tray with some material, or if you're on the technician side of things, you've seen what it looks like a really sloppy paint job on the edges of an impression tray. I think that material is Zoe, and it's made to hold rubber base or rubber-based impressions in. So I'm going to go with calcium hydroxide. Huh. All right, so I was wrong. Glass ionomer cement is for primarily alloy crowns and bridges. ZOE is a cement used in the deep cavity to retard penetration of acids and reduce possible pulp irritation. Aesthetic resin cements are tooth-colored or translucent resins available in a variety of shades, and they are used for bonding all ceramic and indirect composite restoration. So, yeah, fuck that one. Sorry, I messed that one up. So, aesthetic resin is used for your Emax and all ceramic and indirect composite restoration. So, like if you're doing like an inlay or onlay that's actually been done on a model, that type of stuff. Calcium hydroxide is a low strength base. I got it all wrong. All right. One of one. Which of the following dental material is recommended for use with the water-based glass ionomer cement when it is used in a deep cavity preparation? Which of the following dental material is recommended for use? You know, if you have opinions, you're allowed to pitch in here, but you know, if you're doing like actually helping with the study sheet, that's probably good too. Which of the following dental material is recommended for use with the water-based glass ionomer cement when it is used in a deep cavity preparation? That would be the ZOE. Water-based glass ionomer cement when it is used in a deep cavity. We just read that ZOE I don't understand something, so we're gonna find it out. Lime, calcium hydroxide base, is calcium hydroxide, is that just what is the low end impression material? The alginate. Is calcium hydroxide alginate? Is that what this is? Cement. Okay, I don't get it. In which of the following dental material is fluoride incorporated into the powder so that it has an anti-carcinogenic effect as the fluoride leaches out? Both A and B. That was a complete guess. Sorry. Cooling the mixing tab slows the setting reaction time of glass ionomer cements. The cement is ready for use once a skin forms on the surface and consistency becomes noticeably thicker. Is cements even in our freaking study thing? Let's take a look here and see what we can find. All right, so run through our stuff. Cement. Nope, cements are not in our stuff. Model and die materials. All right, which of the following is the purpose of a cast? To provide a working model. Done. Which of the following is a replica of the hard and soft tissues is used to make orthodontic retainers? Well, you don't need dies, models, casts. Casts are replicas of the hard and soft tissues. Study models provide information about oral structures. Okay, when we're talking about the working thing, we're referring to a cast. Which of the following characteristics of the dental material affects the accuracy of the finished model? Flow, expansion or contraction, dimensional stability, all of the above. Yes. Another name for the mixture of model plaster and dental stone is which of the following? We're going to go with orthodontic plaster. It can't be all of the above because model plaster is not another mixture. Yeah. There we go. Which of the following demonstrates the highest resistance to abrasion? And if you don't know, mixing in a little bit of stone with your plaster will actually make the plaster set faster, so that's why they call it orthodontic plaster. I think we can check on that. I bet Whitmix has something on that if you wanted to get distracted. Which of the following demonstrates the highest resistance to abrasion? Abrasion is the wearing away of material from the surface. So, which of the following demonstrates the highest resistance to abrasion? Impression plaster? No. Model plaster? No. Dental stone? Boom. Excess water in a gypsum mix results in which of the following? Increased setting time? Yes. Reduced strength? Yes. Reduced expansion? Yes. All the above. Boom. Differences between plaster stone and high strength stone include which of the following? Chemical makeup, the physical form of the hemihydrates formed when the water is driven out, the presence of calcium sulfate hemihydrates, the physical form of the hemihydrates formed when the water is driven out. Okay. Dental stone is made up of hemihydrates, small, irregular crystals. High-strength dental stone has hemihydrates crystals that are the least porous, most regular, and largest of all the hemihydrates. All right, so dental stone is made up of hemihydrates. Okay. High-strength dental stone has hemihydrates crystals that are the least porous, most regular. So I think both statements are true. And what it's saying is dental stone, largest of all the hemihydrates. Well, I don't think it's the largest of all. Yeah, so I'm going to go with this. Okay. Plaster is made up of hemihydrates, small irregular crystals. High-strength dental stone has hemihydrate crystals that are the least porous, most regular, and largest of all the hemihydrates. All right. Excess water is added to gypsum materials for which of the following purposes? To produce a workable mass, to decrease density, to increase density, to decrease density, to increase density, to eliminate voids. To produce a workable mass. Because of their different crystal sizes and porosity, the hemihydrates of plaster stone and high-strength stone require different amounts of excess water to produce a workable mass. The use of excess water increases the setting time, reduces the strength, and leaves voids. So what this is referring to in the mixing process, if you think about it, so you've got your bowl and you're mixing your dry and your wets, and your wet your dries and you dry your wets. So you're mixing your wet with your dry, and you get to this point where, like, okay, some of the plasters down there work, there's still a bunch of dry. Okay, so I've mixed a little more water in there, and now everything's worked, but it's like seized up, right? So it's not workable. It is all one homogeneous mass, but if you just left it there, it's going to become this very like craggly, angry blob of plaster that you've had to clean out of a plaster bowl before. So instead, what you want is you want to take it just a little bit past that. So you add a little bit more water to it, and you get it into a workable mass so that it's more fluid, it's flowing around, and everything hasn't set yet. It's in the process of drawing all that water in. So, yeah. There we go. Set plaster has the lowest density, or the most porosity, because it had the most excess water. Set high-strength dental stone has the highest density. So far, has dental stone been what they're considering just the top? Because I mean, there's higher, there's like, yeah. All right, both statements are true. Question 11, which of the following is an effective accelerator? Borax, potassium sulfate, colloids, hardening solutions. Pretty sure borax is potassium sulfate. Potassium sulfate is an effective accelerator. Borax is a retarder, and colloids bind to the hemihydrate and interfere with the addition of water to form the dihydrate and a hardening solution. When mixed with gypsum materials in place of water, hardens the gypsum and increases its abrasion. Metal, thank you. Plastic reference. Where? Just the correct interpretation of the fraction 30/100ths means which of the following? It refers to 30 of 100. It refers to 30 grams of powder to 100 milliliters of water. It refers to 30 milliliters of water added to 100 milligrams of powder. I have no excuse. I had a good night's sleep last night. There's no excuse for this. I'm sorry. All right, let's take a look at this. Impressions, casts, and plaster is the only impression material that requires the user's thermoplastic materials and thermoplastic materials. Elastic impression materials. Elastic impression materials flow when first prepared, but set in the mouth to an elastic state. No, to an elastic state. That's right, because they're still flexible. Accordingly, they offer the distinct advantage of flexing to permit removal from undercuts. Except for reversible hydrocolloid, which is soft when heated and sets to an elastic state when chilled, elastic impression materials set by chemical reaction. Currently used elastic impression materials are reversible hydrocolloids, or agar, irreversible hydrocolloids, alginate. Okay, alginate is an irreversible hydrocolloid. Okay, and rubber-based materials, polysulfides, condensation and setting. No, condensation and addition reactions, silicones, and polyethers. So rubber-based materials include polysulfides and polyethers. All remain elastic after setting. Yeah, elastic. So it was elastic, not plastic. Is that right? Found plastic reference tonight or elastic? Am I just missing it? Prepared. All right. If that's plastic, I completely missed it, but I appreciate the input. All right. I like the elastic references, though. Thank you. Which of the following statements accounts for the differences in setting times? We're talking about model and die materials. Final setting time can be detected by dissipation of the heat of the reaction. So you can feel that it's hot. Initial setting time is the interval between the time the water and powder are mixed and the time that the mix can no longer be poured into a mold or impression. That's the initial set, yeah. Initial setting time plus final setting time equals total setting time, yes. All of the above are true and reflect differences between setting times. Boom. The reproduction of detail in an impression depends on which of the following factors: material strength, material hardness, compatibility and interaction of the model and impression materials, setting time. One of these things is not like the other. I think it's this long one here. Boop. Reproduction of detail in an impression depends upon the compatibility and interaction between the model material and the impression material. Let's talk about that. Let's go to our friendly neighborhood Kentucky friends, whitmix.com. And let's go to their resource library. And I bet if we go to manuals for gypsums, gypsum physical properties, holy moly, look at that. That was fast. All right, so let's take this sucker and download it. Yeah. Take this job and shove it. I ain't working here no more. All right. Please, nobody sing that song. It's terrible. All right. How do we go full screen? It doesn't matter. Window, go full screen. Anyway, so now let's look at Whitmix Gypsum's physical properties here. So we're going to scroll down until we get to our model stone. So here's quick stone. So here's our water powder ratio. So remember, it's per 100 grams of powder, not per 100 grams of water. So quick stone is 28 grams of water, or milliliters of water per 100 grams of powder. It is mechanical mixing 20 to 30 seconds. If you're hand mixing it, it is 60 to 90 seconds. I'm going to decrease the size on this a little bit. I'll take it down here so it's easier to see. All right, so we're right here. The working time in minutes is 3 to 5 minutes, and the setting time is 10. So your total time then would be 13 to 15 minutes. I guess is how that works. Or maybe the setting time is your total set time. Your expansion is 0.14, and that's why we were coming here. So we've just got an expansion of 0.14. Now, wow, that was a hell of a yawn. All right, let's go to impression materials, expansion rate. What was it we looked at? So we'll say polyether. All right, here we have Noble Dental Supplies, polyether, it's Impergum. So there's the tray adhesive. That's what I was talking about earlier. I thought that's what ZOE was. I was wrong. All right, so here's Impergum from 3M. Now let's go here and let's find its expansion. All right, here we go. Polyether. Prepare a cast no earlier than 30 minutes later and no later than 14 days after taking the impression. Okay, so it doesn't have the... Huh. Well, I was looking for expansion. But anyway, you can marry... The reason I was doing on this... Wow, I'm a bad host. Hi, everybody. Thanks for joining me. I was trying to see if we could determine what this expansion rate of typical, something like a polyether impression material that we're used to seeing, like the purple stuff, and see what the expansion rate was on that to show that we need to match our expansion rates between our dental stones and the impression materials. So here's your compressive strength after 1 hour and then after 48 hours dried. We accelerate this process by using the hot water bath on our models, and this helps get our hardness up faster because they get them hot enough that they're evaporating off the water that's inside the system, inside the model. But you can see this is hanging up inside of our model room. It's always available as a reference, and you can see what the expansion rates are of the things that you're looking for. So if you need, for example, if you're doing implant work, you want something with a very, very low expansion rate, whereas our dental stone is 0.14, you might be looking somewhere down here, like, or up here. There's an implant stone. They have an implant stone. Mounting plaster. Yeah, so Ultra Rock, I guess, is 0.07. If we looked at, I think we used Palladium's, I think that's still right. We used Palladium's implant stone. And there you go, 0.02% expansion. So for our implant cases, especially full arch implant cases, we use ultra low expansion stone so that we obviously don't want that thermodynamic flexing of the stone with the implant analogs in there, because it changes ever so subtly. It changes the relationship between those implants, and we don't want that. Especially if we have to make sure that we vacuum mix it so the material is very consistent all the way throughout. Make sure that we pour it with very little air getting in. We want it to be vibrated in so that the bubbles are automatically out. And I'm talking about the bubbles on the inside too, because a bubble between two implants would be just as damaging from a thermodynamic standpoint as a bubble would be in the cusp of a tooth. So from an aesthetic standpoint or from a practical standpoint. So that's why it matters what stone we use. We can't just pour everything out of whatever. Also, if you look, let's take a look at the flowstone. So here, you can see that flowstone has a much lower expansion rate than the quickstone that we use. So when you're using that flowstone to get in there, it's just because of the working time and the fact that it's going to set up quickly. So Yeah. All right, there's that. Moving on, let's see if I can finish this up real quick. Where is that one? I was on. Come on now. Yeah. All right, so we were on model and die. Where'd that go? Oh, this is case studies. I lost where I was. Oop. Set plaster has the lowest density or the most porosity because it had the most excess water. Set high strength dental stone has the highest density. This one is the one that's this. Nope, I still got it wrong. Potassium sulfate will accelerate. The correct interpretation of the fraction 3100 means 30 grams of 30 milliliters of water, 100 grams of powder, yep. Which of the following statements accounts for the difference in setting times? All the above. And the reproduction of detail and impression depends on the following factors. There. Increased wetting limits the ability of the gypsum to flow into all the details of the impression. The smaller the contact angle, greater the difficulty in pouring a bubble-free impression. Gypsum flow. Increased wetting. Wetting is the ability for a liquid to all right, got them both wrong. Which of the following statements is true? The strength of gypsum materials is indicative of the ability of the material to resist fracture. Compressive strengths of gypsum materials are relatively the same regardless of type. No. Plaster has the highest compressive strength because, no. High strength dye stone is almost 4 times weaker in the compression strength because of the excess water. No. So the strength of the, there you go. When gypsum is mixed by hand, which of the following is a commonly made error? Not spatulated adequately. You didn't mix it enough. It wasn't spatulated. Now spatulated. That's definitely going to be made into some sort of poster that is going into the stone and plaster room. Get spatulated. All right, which of the following is almost always mixed mechanically? High strength dye stones. Which of the following statements is true regarding disinfecting an impression? Do it. Disinfecting an impression is more difficult than disinfecting of the model. No. Disinfecting an impression limits the introduction of contaminated items in the laboratory area. Yes. Disinfecting an impression, while not as effective as disinfecting a model, is the accepted best practice. No. An impression can be sterilized with ethylene oxide. I don't know. It's this one. And question 20. Polymerization is the chemical linking of the monomer and polyamine. The resin monomer is toxic and allergenic. The resin monomer is toxic and allergenic. Both statements are true. No. The second statement is false. Resin monomer is not toxic and allergenic. The hardener, polyamine, is toxic and allergenic. You scored 80% correct this time. That's a significant improvement from 53%. I will take that. Thank you for joining us this evening. I completed 2 quizzes. Technically, 1 quiz twice. Is that 2.5 quizzes or 3 quizzes? I don't really know. I'm going to give myself credit for something. Go home and have a drink. I hope you do so as well. Thank you for joining us at Russellville Dental Lab CDT Study Club this Tuesday night. Have a good night. I can't put my mouse here because it's actually over here.